So number 22 for the word problems is probably the hardest. So you have two triangles inside of one. So I would set up two triangles separately. That helps me visually. And we're going to be doing substitution. So the first part is it says that Mr. Walsh is standing X amount away from the base of a flagpole, and his angle of elevation is 41 degrees. So we don't know how far he is from the base, so that's why we said X. And so this is Mr. Walsh's triangle, and so we know his angle is 41, and we don't know the height of the flagpole, so we call that Y. So for Mr. Walsh, we want to find the opposite. We want to find the adjacent. So we're going to use tan, TOA. So tan of the angle is y over x. We multiply both sides by x to get rid of the denominator. So we isolate y. We do that so that we can make a substitution. We then look at the blue triangle that represents Friedman, and the angle that we're working with is 19 degrees. Again, we want to work with O and A. Now, notice for the adjacent, it's an expression. Friedman was 300 feet farther than Walsh, but we don't know how far Walsh was from the flagpole. So 300 represents how far Friedman was from Walsh. However, the X represents and Walsh's distance from flagpole is the total for Friedman's distance away from flagpole. So that's one part that's kind of tricky. So when we set that triangle up, again, we were using O and A, so we're working with tan. Tan of the angle is equal to my opposite is y, height of the flagpole, over my adjacent, 300 plus x, the whole length from the base of the flagpole. So again, Walsh plus the distance from Walsh. So if you multiply both sides by 300 plus x to get rid of the denominator, you end up with, so again, if you take this and then we get rid of the denominator, multiplying both sides by 300 plus x, the quantity we put in parentheses, then we have y equals tan 19 degrees times the quantity 300 plus x. So we're then going to do a replacement. If Friedman's equation, you have to use one of the equations. So Friedman's equation is tan 19 degrees is equal to y over quantity 300 plus x. In order to solve for y or x, we can only have one variable. So if you remember, Mr. Walsh's triangle had isolated y, and it was x times tan 41 degrees. So we're going to replace that into Friedman's y slot, and that brings us down to this equation. We only have one variable, so we're going to solve for x. We're going to multiply by the quantity in the denominator, and then on the right-hand side, we have x times tan of 41. So tan 41 becomes 0.693, I rounded. When you then distribute tan 19 degrees times 300, you get about 103.298. When you multiply tan 19 degrees times x, you get about 0.3443x. You're then just doing a basic algebraic equation. You're going to solve for x. So we subtracted 0.3443 from both sides. So on the right, we had 0.525x. We then divided to isolate x. So x, or Walsh's distance from the flagpole, was 196.77 feet. We then know that if we have x, we can go back to any equation. So if we go back to Walsh's equation that says tan of 41 is equal to y over x, we don't know y still, but we know that x is 196.77. So that brings us here. If we multiply by that 196.77, we've isolated y. So y, which is the height of the flagpole, is 171.0 feet. So that's the height of the flagpole. And Friedman's distance from the base of the flagpole would be 300 plus 196.77 if asked that. So for number 23, if you can imagine that a pole is straight up, but then let's say the wind pushes it towards the sun. Let's say the sun's to the left. Only 8-degree tilt, right? So up here we've got the sun. Then we know if the pole originally was set to the ground at a 90-degree angle, that if we had 90 and that 8-degree tilt, this angle for the larger triangle that we're looking at would be 98 degrees. If we know that the angle of elevation is 43 degrees, we know that 180 minus the 98 and 43 gets us 39. So if we look at this big triangle and we also have the shadow and we're trying to find x, the height of the pole, we're going to need to use law of sines. So if we're going to use angle 43 of this big triangle and we're going to use C, we can do side little c, which we know because we know the shadow, over the sine of big C, which we figured out was sine 39 when we subtracted angle of elevation and that 98 degrees, the 90 plus the tilt. We want to find out the A, or x, the height of the flagpole. So you can have one unknown. And across from side A, we have 43 degrees, so sine 43. And when we cross multiply, we get 23.84 feet. Now, some of you might say, well, this x looks shorter than the A, but you've got to remember it's not really drawn to scale, and if this is the flagpole and then it tilts in the wind, the original red is this red. So this is the original flagpole, but it's just tilted. So this little side A is the flagpole that is tilted. So for this next one, we have, it's a little hard, we have this Pine Knob station, and it says that there's a northeast direction looking at the Colt station, which is over here, heading northeast. So if we're going north and then we swing east to that line of sight, that's a 65-degree measure. And then I found out this 15 degrees because if I create a right angle, 65 and 15. Okay, scratch what I just said for a second. So then at the Colt station, if you're looking down, I believe it said southeast, 70-degree swing, and you're looking from that station at the fire, we know that. So we know that with these alternating angles on opposite sides of this line would both be 65. So then if we add 65 and 70, we get this B angle, 135 degrees. Okay, I think I screwed up what I'm saying. I don't have the initial problem in front of me. I think what it might have said is from Pine Knob looking at the fire, I think it might have said that it was an 80-degree rotation. And somehow we ended up with the 15 degrees here. I can look at it tomorrow in class if you have a question on this one. But once we have those two angles, then we subtract them from 180 to get 30 degrees. And then they wanted the distance from both stations, I believe, to the fire. So B would be the distance from Pine Knob. And we could say that A is the distance from the Colt station. So if we use our law of sines, we can do little b over sine b, little c over sine c, and find b, which is the distance from Pine Knob. And then if we want to find the distance from the Colt station, we can do little a, which we have, over angle A, which we have, over is equal to little c over sine c, and we get distance A. So we have both distances. This is from Pine Knob to the fire, and this is from the Colt station to the fire.